Assalamualaikum warahmatullahi wabarakatuh, and good morning, students. My name is Rahmad Tule and I am your new physics teacher right now. In this class session, we would like to learn about the physics concept of vector. So let's get started from the definition first. As you can see here that I already described, vector is a mathematical representation of a physical quantity that has both magnitude and direction. So, what do we mean by that? Let me give you some example in physics of the kind of things that you're going to encounter. You're going to encounter forces, so we can represent force with an arrow. Well, let me explain a little bit more here. In this case, when we draw an arrow to represent a vector, the length of this arrow, the length of this vector, represents the magnitude of that vector, the magnitude of that quantity. For example, if we talk about force, if I draw a long vector, if I draw a long arrow, I talk about a large force. And if I draw a short vector in same direction, I talk about a small force. So the difference only here, the only difference here, if it's long, it's large, and if it's short, it's small. Alright, now if I draw an arrow, for example, in this direction, notice that the length of this vector and the length of this vector are same. The magnitude of that vector would be the same, and just simply the direction would be different. So definitely we use an arrow to represent a vector, and the length of that arrow represents how large that quantity is, and the direction of that arrow represents the direction in which that quantity is acting. In case of force, in this, it would be acting to the right, and for this, it would be acting in this direction. Here I have a little drawing of somebody pushing a box, and so that person exerting a force on that box, and the direction of force is came from left to the right, and the length of this arrow, the length of this vector is represent how large, how big that force is. Here I draw a charged object, let's say a positively charged object, and I draw lines in all directions, different directions, represents the electric field around this charged object. And the length of this arrow, the length of this line represents the magnitude of electric field. And of course, as you can see here, all the lines, in the different directions represents the electric field goes out in different direction too. Alright, here I have a soccer ball, and the soccer ball gets kicked in this direction, so it will have momentum. Momentum just simply a product of mass, which is scalar quantity, times with velocity, which is vector component. So the result of that is a momentum P. P stands for momentum, and that's also a vector quantity. The longer I draw the line, the longer I draw this arrow, the greater the momentum, which means the greater of the mass or the greater of the velocity. And of course, the direction of this momentum, the direction of this vector, you can see in this direction. Here I draw an example of car, and it's traveling from left to the right, and it has a velocity. It's like a speed and direction combined. The length of, of this vector, the length of this arrow, represents how fast the car is moving, and the direction shows you the car movement. I didn't mention another word. I mentioned scalar word. So let's compare between vector is and scalar is. Vector is something that has both magnitude and direction. For example, velocity. Velocity can be fast or slow, so it's the magnitude. But velocity has a direction too. So that's make velocity is a vector component. But scalar it only has magnitude. For example, mass. Mass is only how much stuff is in it, and it not has no direction in mass. So that's why mass is scalar component. So the conclusion is vector has magnitude and direction, but scalar just only has magnitude. Alright students, that's all what we can learn today, and I hope you all understand what you have learned today. And see you in the next class.